So now we'll be having a look at some practice questions related to the equations of motion. In your syllabus, you have these three equations of motion. V equals u plus at is the first and the easiest one. The second one is S equals ut plus half at square. This is the second one. Third one is v square equals u square plus 2as. This is the third one, right? And you obviously need to know what each of these symbols stand for. So here u is what we are referring to as the initial velocity, right? Keep in mind this is initial velocity, not speed. V is similarly the final velocity. S is the displacement. And A is the acceleration. And last, T is the time. Right, so this is what each of these symbols which are used in these equations stand for. U is initial velocity, V is final, S is displacement, A is acceleration, T is time taken. With the exception of T, all of the other symbols U, V, S, and A are all vector quantities. So all of these are vectors, right? And obviously then time is a scalar quantity. Let's also, before going on to the example, talk about the validity of equations of motion. When can you and when can you not use the equations of motion? So the first one is that the motion has to be, the object must be moving in a straight line. So if that object is not moving in a straight line, if it's moving in a curved path, for example, then you cannot use the equation of motion. The other one is that the acceleration must be constant, right? So that acceleration or the deceleration for that matter has to be constant in its magnitude, in its direction, because acceleration is also a vector quantity. Whenever it's not constant, you cannot use the equations of motion any longer. So let's have a look at some of these examples. So the question says that a train starts from rest at a station. So from rest, this is something that you'll learn a lot when doing these questions, that starting from rest basically means that its initial velocity is 0. And this is, by the way, the best way to approach any question related to kinematics, is that as you are reading a question, you get some hints and then you just accordingly write those symbols here. So from rest means that its initial velocity u is 0. Because once you do this, it will be very easy for you to then single out which equation of motion to use in each case. It then accelerates at 0.2 meters per second square. So now you also know that the acceleration is 0.2 for a minute, right? So for 1 full minute, so the SI unit for time is seconds. So this means a time of 60 seconds until it clears the platform. Calculate the final velocity of the train and the length of the platform. So this is basically a two-parter question. So we have U, A, and S, and the final velocity, what we need to calculate is really V, right? And actually I just realized I made a mistake. This is actually the time, which is 60 seconds. And then the length of the platform would basically be the distance traveled by the train, which is also what we need to find out. The order really doesn't make a difference. Whatever you want to go ahead with, you can. So you have U, A, and T, and you need to find V. So if you think about this, and you do need to have a blueprint of the equations of motion in your mind, this is what any good student would have in order to tackle these questions successfully. So which equation has U, A, and T, U, A, T, and V involved? It's the first equation of motion. V equals U plus AT. So U is 0 here, so V is just AT. So 0.2 times 60. So the final velocity turns out to be 12 meters per second, right? This is the final velocity as it clears the platform. And to find the distance, basically the length of the platform, if you think about it, you have u, a, t and v, and you need to find s. So then, because you only have 5 variables and you found 4 of them, then you can use any equation of motion you want. You could also use s equals ut plus half at square, or you can also use v square equals u square plus 2as. Both would give you the same answer. So just to avoid rearranging the equation, I'm using this one, ut plus half at square. Again, u is 0, so this entire term becomes 0. So all I have is half 0.2 as a, and the time was 60, so the square of 60. So this value then turns out to be 360 meters, which is the length of the platform. So the next part of this question, so the above was part A, and then part B says, this says that it now accelerates at 0.4 meter per second square for the next 540 meters. So previously it was accelerating at 0.2, now it's 0.4. For another 540 meters, find the final velocity and time taken to travel this distance. So I just told you guys that this is the second part. So can I say that whatever was the final velocity at the end of the previous stage of the journey is now going to be the initial velocity? So the final velocity of the previous part was 12. So that will be the initial velocity now. So u is 12 meters per second now. And then the acceleration is 0.4 s. The distance traveled is 540. And we need to find v, and we need to find t, right? So again, order really doesn't make a difference. So for finding v, I have u, a and s. So which equation of motion should I use? And the answer again, so only once when you have a blueprint of the equations, either in front of a paper, either on a paper in front of you if you are just starting out, or in your head, only then will you be able to recognize which equation of motion to use. So v square equals u square plus 2as will be our equation of choice here. So u is 12, so 12 squared plus 2 times 0.4, and s is 540. So using this equation, when you take the square root on both sides, v square turns out to be 576, so v turns out to be 24 meter per second, right? And then the time to travel this distance. So again, at the end of this, I have u, a, s and v. So for any equation involving time, I can find t. Let's use the easiest one then, which is v equals u plus at. So 24 equals 12 plus 0.4 times t. So using this equation, 24 minus 12 would be 12 again. So 12 upon 0.4. So this time would be 30 seconds, right? Let's do a bit more. Some more questions. So the final question is this, slightly different flavor of question involving deceleration now. So an aircraft lands on a runway at a speed of 40 meters per second and brakes to a halt. So what does braking to a halt mean now? It means that the final velocity is 0 in a distance of 860 meters. Calculate the braking time and in part B the deceleration of the aircraft. So if I again read the question and try to understand what values have been given to me, so I know that the initial speed, the initial velocity is 40 meters per second. So u is 40. So u is 40. And it brakes to a halt, so it comes to rest. So the final velocity v is 0. And the distance traveled during this deceleration is 860 meters. And we need to find the braking time in part A, and in part B, we want to find the deceleration. So do we have an equation which links u, v, s, and t? So we don't really have one. So it really doesn't make a difference. We can calculate A first, right? So do we have an equation which involves u, v, s, and a? We do. It's v square equals u square plus 2as. V is 0, so the square of 0 will also be 0. So 40 square plus 2 times A is what we want to find, and S is 860. So when you do the math for this is negative 0.93 meters per second square. And now that we know the deceleration, so we now know U, V, S, and A, and now if you want to find T, again let's just go with the easiest one in terms of the working. So V equals U plus AT. So 0, U is 40, A is negative 0.93 T. So to avoid rounding error, just go ahead and use whatever value this is in your calculator. It was negative 40 upon 43, so let's just use the exact value. So 40 divided by the negative of this answer. So this turns out to be exactly 43 seconds. So this is how you deal with equations of motion. Whenever reading a question, write down the values that are provided to you. Some may be directly given to you as numbers. For others, you may need to read a bit between the lines. And then once you have these variables down, list down what you know, list down what the examiner wants you to find, and then from these equations of motion, you just see which one you are going to use in each scenario.